Okay guys, so let's start to solve this question. So in this question we are going to see how to count the nodes that have greater values than ancestor. So let's first understand the question. So let's say we have a root node that has value 1, okay? And it has two childs. The left one having the value 6, and the right one having the value 2. In the same way, 6 has a left node having value 7, right has the right value, and right has the right value having value 4. The 6 has the right value having value 8, and so on. Now we have to find out how many nodes have the value that is greater than the previous all its ancestors. Let's go to the code. I have already prepared the tree in such a way. I will have to make one change, is here of the root dot left dot right dot left, that is this one, root dot left dot right dot left. I will change the value to 7 as is in our history. Okay. So now we have the same tree in here. This is the tree class. To find out which no, find the count of the nodes which have the value greater than the all their ancestors. So the value the node has its value greater than all ancestors when, let's see how which nodes have the value greater than all its ancestors. So 6 has the parent as 1, so it is greater than its ancestor. Also 1 has no ancestor, so we can take it the parent of 1 does not exist, so we can take this node. And then if we see 2 also is greater than 1 and its ancestor, and 4 is also greater than 2 and 1, so we will take this 4 also. 5, 6, 10, then 3 and 7 also, and 8 is also greater than 6 and 1, so 8 is also counted. Now we come to 7. 7 is not greater than 8. It is greater than 1, 6, but it is not greater than 8, so we will not count it. So in total we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for this tree we should get the count as 10. So let's see how we will program it. So as we are dealing with tree, we will write a recursive program. To first trigger this problem, we will have a trigger function that will call another recursive function in it. So let's call it static because I do not want to make any instance of without hence I want to call this method without making an instance of an object. Static is for returning the count and then the name of the method. Completed node, and we will accept here the tree node, the root. Then we will return the result of another function, that is the recursive one. We will write another static function. Count. So let's think about it. What do we need? We need to pass the root node. Then we need to pass the maximum count which the ancestor has. This is in pen. To check that the node below, node at the end has, or node at the present node is greater than all its ancestors, we will have to check the maximum value in this. 168, the maximum value is 8, so we will have to compare it with 8 so that we do not count the same. So in here we will need to pass one tree node, that is the current node. And then we need to pass integer, that is max, and again an integer, that is the count, that we will return at the end. So in recursion we will want to have a edge case or the base case in which the node should return, the recursive code should return when it's at the end of the tree. The end of the tree is when the node is null. So let's say when current node, if statement is current node is equal to null, then we will return the count as 0. So this is our base case and it will return 0. Then what we have to do, let's go back to paint. So every time here at a node, we will have to traverse left and to the right and get the maximum and check if the value there is greater than the previous one. So as we are passing max, so when we traverse from here 1 to 6, we pass 1 as the max value here. So when we are at this node, we will have to check if the current node is greater than the max value and then increase the count. Also we have to go iterating over to the end of this tree to the leaf nodes and check if it is greater than the max of these two, both of these. Okay, so we will need a max function. We will be importing the h prime port blank and here we will return count, return the left and right, sum of left and right node. So how it works is like the one, as we call this left and right. So in here we will get 3 nodes that are greater than these ancestors, and in here we will get 1 2 3 4 5 6 nodes that are greater than ancestors, and plus 1 this original node. So in total we will get 6 plus 2 is 8 plus 1, 6 plus 3, 9 plus 1, 10. So in total we will get 10 that are greater than their ancestors. So we need to sum the left and the right for each node that has the branches. So we will be going to return. We'll call this function again. Node will pass the current dot left so that it goes to the left side, and we will pass the max as current value. Comma current. The val is greater than max, we'll pass max. According to max is greater than, we will pass, and the count we will pass. In here, what we need to do again, we need to add the same code for the right one also. The count which we have here. Is this enough? No. We will have to increase the count at every step whenever we found that the current node is greater than its ancestor. We'll write an ternary operator, or maybe directly write a if statement get ternary statement. So if current val is greater than max that we get from the parameters, current val is greater than max, then you do count which we get from here, we'll do count plus 1, else we'll return count. And addition of all this. So this handles all of the cases, and in here function will pass the root. Max we will pass as the one has no parent, no ancestor. We'll pass the minimum value of the integer dot minimum value, and we will pass the count as 0, and for the starting the count is 0. And in the main function we will call this triggering function with the root node in it. We'll run this. To print it, as you see, we got the answer as 10. We had calculated from our. So let's change one more node in here. Let's say we change this 3 to 11, or maybe we will change this to 11 so that all this node will be deleted. So to change, we will have to change one dot root dot right node to 11. So root dot right node is this one, is 2, change to 11, and then run the code. So it gives the answer 5. So let's see if our answer is correct. With green circle now. This root node is always greater than its ancestor is present. Then this node, or this side of nodes greater 4, then we will calculating, and this also 11 is also greater than 1, we will calculating this 5. Then 3, when we come to 3 is not greater than its ancestor, that is 11. Also 10 is not greater than its ancestor, it is greater than the ancestor 3, but it is not greater than the ancestor 11. Same case for 6, 5 and 4. So at last we will get only 5 nodes, 1, 2, 3, 5 nodes. So our code is now correct. Okay, so this in here this video ends, and thanks for watching the videos. Please like, share and subscribe this video for more contents. I will be uploading more of them.